In this video, we are going to be looking at direct variation. Now, let's say we have a quantity A and then we have another quantity B. Now, if an increase in quantity A results in an increase in quantity B and a decrease in quantity A results to a decrease in quantity B, we say that both of them are directly proportional. In other words, this is an example of direct variation. Now, as a means of illustration, let's say that a boy eats this quantity of, let's say, bread, and then the boy is this fat. And then he eats this quantity of bread, and then it becomes this fat. So you can see that an increase in the quantity of bread leads to an increase in the weight of the boy. And this here is direct variation. Does that make sense? Let's take examples. And if P varies directly as Q and P equals to 8 while Q equals to 2, calculate P if Q equals to 6. Now, by the right hand side here, I have steps you need to take to be able to solve this question. Number 1 is express the variation mathematically. Number 2, introduce the constant. Number 3, slot in the values and find the constant. Number 4, find the unknown. Now we are going to go through these steps together to be able to solve this question. Does that make sense? So the first step is to express the variation mathematically. Now let's read the question. If P varies directly as Q, now how do we represent direct variation mathematically? So we are going to be having P varies directly as Q. Can you see? This is the variation symbol. P varies directly as Q. Let's go to step 2. Introduce the constant. Now to introduce the constant, we are going to turn this variation symbol to the equals to symbol. So we'll be having P equals to KQ. Can you see? As soon as you turn the variation symbol to equals to symbol, you have to introduce the constant. In this case, K is the constant. Any letter can be the constant. It can be C, it can be B. But in this case, I'm choosing to use K. Does that make sense? Now, before we go to step 3, I would like to name this equation 1. Does that make sense? Now let's go to step 3. Slot in the values and find the constants. So what are the values? If you look at the question, we are told P equals to 8 and Q equals to 2. So we slot it into equation 1. P equals to 8 and Q equals to 2. Now we are going to slot it into this equation. So what that means is anywhere we see P, we call it 8. Anywhere we see Q, we call it 2. So we'll be having 8 equals to K times 2. Do you understand? P equals to KQ. So 8 equals to K times 2. The second part of step 3 is to find the constant. So to find the constant, we divide both sides by 2. 2 cancels 2. 2 here 1, 2 here 4. That means our constant equals to 4. That is K equals to 4. Does that make sense? So before we go to step 4 to find the unknown, we have to put K equals to 4 in equation 1. So what that means is that wherever we see K in equation 1, we call it 4. So we'll be having P equals to 4Q. Now we can go to step 4, find the unknown. Now if you go back to the question, we are told to calculate P if Q is 6. So let's continue somewhere here. So we're told to calculate P if Q is 6. So we know that Q is 6 and we are told to calculate P. So anywhere we see Q in this equation, we are going to call it 6. So we'll be having P equals to 4 times Q is 6. So 4 times 6. So it means that P equals to 4 times 6 is what? 24. So don't forget, all you need to do is to follow this step. Number 1, express the variation mathematically. Number 2, introduce the constant. Number 3, slot in the values given and find the constant. Now, before you go to step 4, which is find the unknown, you have to put the constant back into the equation. Does that make sense? Then you can find the unknown.